Hey everybody, welcome to the workshop. In today's episode, I've got a new tool for the jewelry studio. It's a Sherline micro mill. Now, in most cases, people like to do a lot of the work with, say, like the Fordham here, or say like using a jeweler saw and cutting the stuff out. But for me, I'm a power tool guy. I love power tools, and while I'm perfectly okay with using hand tools, I prefer to avoid it if possible. I find that I get better accuracy out of power tools, and say like in the case of the jeweler saw, I have had it before where I was cutting something, having to cut a section off of a ring, and it just felt like it was absolutely taking forever trying to just saw through the thing. So I already can do a small amount of machining, and so because of this, I started looking around for mills and lathes, and I'd like to get one of each, but I can only afford one at a time. So I've got a project in mind that I want to do, and the mill was going to be the better choice for the beginning. I still want the lathe, but I'll do that later. Now the Sherline brand is what I'm calling micro mill and a micro lathe, because they are very small, but they are still metal mills and metal lathes, but they're made for small stuff. Say if you want to do watchmaking and you're trying to work with very small parts, these do have that capability. They're not like the antique ones. Those are probably the best, but let's face it, some of those small ones like that are quite expensive, and you've got to do a lot of work to actually get them back up and running. So I've chosen this right here for what I want to do, and I have done some watchmaking in the past as well, so you never know, it might come in handy for that one day. But for right now, I'd like to do it for the jewelry making. So today's episode, I've got it sitting right down here below you, and I'm going to unbox it and see about getting it put together. So follow along with me today on Adam's Workshop. Okay, we're going to start off the unboxing by taking a look at some of the things that came not inside the main box, but inside the packaging box here. Starters, we've got a shop guide, which all the shop guide is showing you all the different types of parts and accessories that you can get for like the mills and the lathes. So this will be something I'll look at later. We got some of the tooling here. Right here is a T-driver. Looks like it got a little bit hot at some point in time there. Got a little sticky. But it's just an Allen key, so it comes with a tool. Here we've got a fly cutter. This will definitely come in handy. So we got the fly cutter here. That's pretty cool. And this is going to be the little drawbar that screws into it, which this is going to go through the mill head and screw into that, but that's actually how it gets held in, so that's kind of cool. It comes with its own drawbar. Okay, looks like we got center drill set here. Woohoo. I don't know if you can see this, but man, is that tiny. It is double-sided. And there are two others to go along with it, a little bit bigger sizes. This is the collet set, so anytime you're going to have something as small as these center drills, you're going to have something to do it. You can use a Jacob's chuck, not the best choice. Collets really do a better job of holding it. And once again, comes with its own drawbar. Pretty cool. Comes with 3 different sizes, which says 1/4, 3/16, and 1/8 inch. So 3 different collet sizes. Yep. Now we got a few items here in boxes. It says it's a step block hold down set. Okay. Yeah. If you are familiar with mills, you've got to have some way to be able to hold down to the bed. And so if you're not using a vise or you can't, then you can use these little step down holders. Let me take it out of the package so you can see. Looks like this little triangle that's serrated, and so what you'll end up doing is you'll end up putting two of them together and then put a bolt in there, and that actually bolts down to the bed and is able to hold down parts. We've got the mill vise. Pretty awesome. Pretty small. Get a sense of it there. There's my hand. You can see it's actually pretty small, but this is a small lathe, so we're not going to be dealing with anything really big here. We got an end mill set, 4-flute end mill set. So we got a nice little block of wood here to put the end mills in. Take one of them out. Okay, so here is one of the end mills. So we can see it's actually double-sided. This particular one is a 4-flute. And that's what we're going to be using for a lot of the operations here. So instead of having to use a saw and just going to town, at least for me, seeming like it's taking forever, this right here can do the job for me. And while this is not quick either, it still keeps me from having to sit there and wear out my shoulder and my hands trying to sit there and saw the thing to get solid. So this is the Y-axis way cover. This is going to be good for keeping the mill clean. I'm not going to take this one out of the package, but basically it's just like a piece of plastic that's set up like an accordion, and so as the axis goes in and out, up and down, depending on which axis it is, this right here will expand and contract to go along with it to help keep all that clean. So that way it stays in good working order. And then we've got the drill chuck and drawbar. So we got our drawbar here, and there's our key. It's a tiny little thing. And here is our Jacob's chuck. Okay, now that's everything that came in the package that wasn't in the main box. So the next thing is going to be actually taking out the entire thing and starting to see about getting it assembled. Okay, first thing we have here is we've got the assembly and instruction guide, so hopefully that's going to be helpful. If you've ever bought anything and tried to assemble it, you know that some companies do a better job than others of making a good instruction guide, so we'll have to see how this goes. Next we have two cards here that came with it, decimal equivalents and tap drill size, and also metric decimal equivalent and tap drill size. So that's cool for a nice little reference. Looks like we've got a belt and bracket and some hardware. Okay. Looks like we have the drive spindle here. Now the one that I did order since I didn't order this off of Amazon, I ordered off of Sherline's website, and they do have an option on there for upgrading the headstock spindle. So that is something that I also did. I also opted for the longer Z-axis as well, because it's standard 10-inch, and I got the 15-inch upgrade to give me a little bit more, because I kind of started thinking about it. Once I get the vise onto the bed, I get the drill truck in there, and I get if I got a drill chuck, I'll say it right here in a minute, and then a drill, or even if I'm just using the collet, but especially if I'm using the Jacobs chuck and say a drill bit for something, then that's going to really reduce the amount of working area that I have. So I opted for the longer one. Okay, so now we've got the control module, the on-off switch, and your variable speed. And it looks like a mounting bracket to go with it. Okay, and our drive motor. All right, and here's our extended Z-axis. Looks like we've got a little oiler right here. According to this, it looks like you can actually maybe rotate the head side to side with this. And then here's your up and down. First impressions on this, it looks like it's pretty good. Everything looks like it's pretty solid. Hand wheels feel like they're made of possibly aluminum. Don't see any. I can see some milling marks up to right here, but I don't see that that's probably going to hinder in anything in any way. But I do see this. But other than that, it looks like it's okay. Looks like it's made pretty well. The Sherline line says that it's made in the USA. This is how the table come mounted inside a box with some wood to help keep everything from getting damaged. So that's a good thing. And the tool provided actually will take it off. That's good. Oops. Okay, now that I've got this out, first impressions of the pieces before getting it assembled and turning it on for the first time is, it looks to me like the graduations on each of the hand wheels looks like it's definitely been cut into it because my fingernail is catching on it, so that's nice. It's not just painted on or something like that. It's actually been cut into it, so it should last longer. Now, I don't know why you would be getting so rough with a thing that you would be grinding it off, but I do know that paint can fade and wear off over time, so it is nice that these have actually been probably laser cut into there. So that's definitely nice, and it is white on black, making it really, really easy to see. Now the hand wheel, it turns very smoothly. It's turning very smoothly in both directions. So from the factory, everything seems to be tight, everything is smooth, seems like it's actually pretty good. So far, the turning of the hand wheel for your Z-axis, your Y, and your X-axis all seem to be in very good shape from the factory. A lot of times you have to do you may have to do some tweaking here and there, and I'm sure there might be some coming down the line when it comes time for me to put all this together. But so far, just first impressions, it feels nice. It's not heavy. I think the manual says that it's like 42 pounds total. So the whole thing is obviously what I'm calling a micro mill. On one of my previous builds, you got to actually see me use what I would call a mini mill, which is the next size up from this. And so that one is what I would call a mini. This one I'm calling a micro because it's even smaller. The one outside, the mini mill, is about 130 pounds-ish. This one's 42 pounds. It does have the mounting holes here, and it's probably going to be recommended to actually bolt it down because that's the way it is for most of them. All of them, actually. The more mass that you can have, the more stable these things are going to be. So if you bolt it down to a good, solid, sturdy work surface, that's going to help your overall accuracy quite a bit. So, but everything looks good, everything feels good, everything is moving very smoothly. The little rotating handle right here is looking good, feeling good. It's just plastic, but still feels good. It's still turning very smoothly, very easily. So first impressions, very happy. Everything looks good. It looks like it's come with everything. So it's going to be interesting getting to put it together and getting it set up, getting it trammed in. So this is going to take some time, but this is my first impression for this tool. So at the moment, I'm feeling pretty happy, pretty confident in my purchase. So we'll see what happens when I go to put it together. Okay, it's assembly time. And the first thing we're going to do is we're going to put the Z-axis onto the bed here. So the first thing we're going to do is, it comes with this brass tube to help protect the screw here, so we're just going to take that off. And I was trying to figure out the best way to do this, so it seems to me like if I take the table and stand it up, and it's got these two bolts here to bolt it in, it does stand up. I'm going to take the Z-axis and lay it down this way. And right now I just got it laying here on the motor, so that way it just kind of helps hold it up. Take both screws, and the way this thing is set is we have two bolts, or two holes here in the bottom, and they're offset. Now there are multiple holes here. It's going to go in the top left and the bottom right is what we're going to do. So I'm going to put the bolts in first. And the T-nut tool here is the one that actually fits these. So now I'm going to bring it up here, and I'm going to have to hold it up just a smidge to get them started. Oh, I was wrong. I guess it's this one. Yep, this one. I was wrong. It does come with a couple extra Allen keys though. And now we just tighten these down. Okay. Okay. Now we can set this to the side for the moment. And we are going to work on the headstock and the motor. Now this feels a little bit funky doing this. I've been trying off camera to try to figure out exactly how to put this together. We do have this split belt guard here, along with some couple of standoffs, and this little piece that's got a nut on the back side of it. Trying to figure out how all this goes together. But first thing we're going to do is to take these two bolts right here off the headstock. And the reason why we're doing this is because we have this L bracket here that has got to bolt onto it. Now the orientation for the bracket is, you can see there's two holes here, and if I turn it this way, there's two slots. The two holes are going to go towards the headstock. The slots are going to go and bolt on to the motor here. Okay, so as you can see, the bracket gets really close, but it is not hitting the pulley here. Okay, we can set this to the side for the moment. Now comes the fun part. We're going to take one of the Allen heads that's provided, and we're going to start off by taking off the pulley. And notice the pulley is almost all the way to the edge here, but the shaft is sticking up just a tad bit. So I'm just keeping note of that, so that way I can put it back the way I pulled it off. It just has one little set screw in here that holds it in place. At least I'm pretty sure it's just one. Yeah, it's just one. Ooh, that's on there good and tight. And for a lot of the pulleys here, it is round on the inside, but pick it up again to show you it does have a flat spot right here. You can see there, and that's where the set screw gets tightened in. Matter of fact, even right here, I don't know if it's showing up on camera or not, there's even a little score mark right there where the set screw was tightened down on it. But the flat spot is where it tightens down onto. Okay, first thing is we're going to take the plastic guard and we're going to put that on. Now we actually get to put the pulley back onto it. And I'll try to get it back on there the best that I can, as close to where it was at from the factory. We may have to adjust this to make sure that the belt lines up with the pulley on the headstock, but we'll have to deal with that in a little bit. Next thing is we have the two standoffs. They look a little hexagonal here, and they do have detents in them for it to sit into the plastic. So there are 4 holes on the face of the motor here, and I'm just going to pick 2 of them and screw these into it. And now I'm going to make sure that the plastic guard actually gets into that as I screw them down. Okay, got my wrench. I'm sure these don't need to be cranked down on like your life depends on it, but I do want to snug it down and make sure they are on there solid. So, and these are aluminum too, so it's not steel. Okay. Next, we are going to put the belt on. Now, we're going to put the other side on, and it's going to line up on the inside of here, like so. And the instructions say we're going to screw these screws into here. On the back side of where these screws are coming through, there are cutouts in here specifically for the nuts. So we're going to install the nuts before I get it all the way on there. And now I've got to go get me a Phillips head screwdriver because apparently I'm not prepared. Okay, I'm just going to hold the nut on the back over here, even though it is retained. And this is plastic, so don't be cranking down on it. Okay, I think this one is supposed to now slide inside of here, but I'm going to have to do that afterwards because it's pretty loose in there. So now the speed control module is supposed to be able to set right down in here. You got two holes. See if I can get this thing turned around better. Okay, as you can see here, maybe, there we go. You got the two little holes right here, and on here, right here and right here, fit into that slot, or those holes. And the manual says it's got enough spring to it, it should be able to spring out of the way and spring back into position. Let's hope we don't break it. Aha. Okay. And it actually is able to hinge on there. Okay. Now we should be able to, there should be a bolt on here for this. And a washer, it looks like. So we got the bolt and the washer. The nut should fit into the slot here. Okay, that should fit into that slot. It's not wanting to fit. Okay, I think I was getting a little bit ahead of myself here. The next step needs to be bolting the headstock onto the motor right here. So we're going to do that first. So we've got two bolts, and it actually shows to have two washers on each one of them. So we want to put that on. And these slots, these holes are slotted here, so that's actually how we're going to put tension on the belt. If you can't tell, this thing's just slightly awkward. I guess it'd be helpful to put the belt on first. Okay, got the belt on. A little bit awkward, but now we're going to put tension on it by holding on to the headstock and pushing on it. Best way I can do it is push on the plastic here, put tension on the belt, and then we tighten it down. Checking for alignment, make sure nothing is going to pop off of it. Looks like it's pretty good. Now, I think we are ready to put the nut plate in here. And then tighten it down, I think. Okay. It feels pretty rigid. everything is nice and tight. Now, according to the owner's manual here, it looks as though that this setup looks to be the exact same thing on the lathe. So if you're like me and you get the mill first, which I do intend to get the lathe later, I'm not made of money, so, but this setup is going to be, it looks like the exact same thing. So if you put it together once and then you get the lathe later, or if you get the lathe first and then you get the mill later, you'll already kind of know how this thing goes together. So now that we have this assembly, now we've got to put this assembly, attach it to here. So clean up the work surface again. Okay, now how this is going to assemble is you have this piece right here, this little knob right here, that it is going to fit onto. Let's see if you can see right there. There we go. You got the hole right there, and on this side right here there is a set screw, and that's going to how it's tightened down. Now you notice we've got this little channel right here, and we've got this little piece of metal right here. That is going to register on there. So that is extremely nice that they have that way to register this thing on here. So, and it is with the T-handle again. And there we go. Now that thing is on. And it actually feels pretty tight for that too. I'm glad that they have that piece of metal in there to register the thing again, so that way it's not, you're not trying to do all that kind of mess with. Okay, make sure this is off. I'm going to plug this in and turn it on for the first time just to see what it sounds like. Now that's all the way up, and it is pretty quiet, which I would hope it would be kind of quiet for something so small. What I was feeling around for is just to feel the vibration. There is some vibration in this, which, I mean, after all, we have a rotating motor and the whole thing is bolted on this way too. So this is not a traditional mill setup necessarily. One thing to note about mills is, and lathes, is that they absolutely need to be bolted down. Even something this small, doing some of the really tiny projects that I'll be doing, the more rigid one of these machines are, the better it's going to perform. The more of that vibration that will get transferred down to the table and help it to stay more rigid, help it to not vibrate as much, and this is what we want out of a tool like this. So, one other thing to check. Obviously there's a little bit more resistance as I'm turning the Z-axis up than down, but the action is still quite smooth. So this thing is quite nice. So Still, my first impression is still the same as it is for the unboxing. It feels quite nice. It states that it's about 42 pounds. It almost feels lighter than that to me, but you know, pretty close. I don't really have the setup, the workbench just yet to be able to bolt this down where I want to permanently. So, we'll see. But as of the moment, I'm quite happy with it. It does feel like it's high build quality. Like I said, it is made in the USA. Not exactly cheap. This mill is significantly smaller than my other mini mill that I have. I have a wind mini mill out in my shop, and this thing right here weighs probably about 1/3 of the weight of the other one. But this sucker definitely feels high quality. It is not made for heavy duty applications. This is great for model making. This is great for possibly watchmaking, jewelry making, anything where you're making very small parts. So regardless of the type of machinery you're working with, whatever type of tool you're working with, always keep in mind that it has limitations. What is the work you're going to be doing? Don't buy a tool and then think that it can do everything. Buy the tool that is going to work best for the type of projects that you're going to be doing. So if you're going to be making large projects, if you're going to go into business and you're going to be making a lot of big projects, a lot of big parts, then you need a big floor stand mill or lathe. If you're going to be doing something medium size, get you a more medium size. But if you're a hobbyist, get a hobby lathe. A lot of people will say that they're not accurate. Well, they're not going to be perfect. I mean, for crying out loud, Jesus is the only one perfect around here, not this equipment. But if you are willing to take the time and effort to put into these machines, then they will perform to the level that you put into this. Always keeping in mind they're not going to be perfect. So, for what I'm going to be doing with it, I think this thing is going to be absolutely perfect, and I'm really looking forward to it. So, with that said, if you enjoyed this video, if you found it helpful, please like, share, and subscribe, and I'll see y'all again next time in the workshop.